In this video, we'll explore the idea of canceling, in particular questions around what we can cancel and what we cannot cancel. So you'll see on this page that I have the questions, what can I cancel and what can't I cancel? So I'll go through some key points for identifying how and when we know if we can cancel something, and then I'll show a couple of examples that demonstrate this. So to start, the first thing we want to know is that identifying the operations is really important. So far, we've simplified rational expressions. We've also multiplied and divided them. We've added them, we've subtracted them, and then we've looked at complex fractions, which is essentially a rational expression inside another rational expression. So as we work through identifying what we do and when, one of the biggest keys is to identify which operation are we dealing with. It sounds simple, but with as complicated as the processes of working with rational expressions can be, it's something it's easy to lose track of. The next thing we want to focus on is that only factors cancel. When we're looking at an expression that's added or having various terms, those can't cancel. And so it's only factors, things that we multiply, that are going to cancel. If we think about why this is, it's because canceling, which is kind of an informal term, is actually dividing, and division is the opposite of multiplication, not addition or subtraction. So things that we are multiplying can cancel. Things we are adding or subtracting cannot cancel. Now we'll go on to a couple examples. I'll start with a numerical example, which should be a little more comfortable because we'll know whether the numbers we're working with are right or wrong, and then we'll move on to an algebraic example. For our first example, let's look at a numerical example. So we're just going to look at a rational expression that's really just a fraction. It's just going to have numbers in it. So let's take something like 2 plus 10, and that'll be divided by 2. So the question that comes up is, can I cancel these 2's, right? And when we're looking at these as numbers, we know that according to the order of operations, that division bar is a natural grouping symbol. And so we'll look at the numerator and denominator separately. The numerator has 2 plus 10, which is 12. So we've got 12 over 2, and we know indeed then that that equals 6. So if we're looking at 2 plus 10 and wanting to cancel those 2's, there's no way that that could equal 10, right? So what's happening there is we've got addition between the 2 and the 10, and then division. So the addition can't be reversed by this idea of canceling, which is really division itself. So there's no way that we could cancel those 2's. We'd have to just simplify that numerator. So to summarize this, we had addition as our operation. And if I ask myself, could I cancel? The answer there was no. Let's go to a very similar example, but let's do one with multiplication. So if we have another number, we're going to take 2 times 10 over 2. Now, according to the order of operations, in a very similar way to what we just did, that can become 20 over 2, which is then 10. And so if we look at this one, and we think about canceling, could we take 2 times 10 over 2 and cancel those 2's? And we absolutely could. And the reason is that we're working with multiplication. So 2 times 10 over 2 is indeed 10 there. So if we summarize that one, we had multiplication in that numerator. And could we cancel? Yes, we could. For this last example, we're going to do a really simple algebraic example. And I'll make it similar to the one we just did that only had numbers. I'm going to take an expression like x plus 10, and then I'm going to add in that numerator x plus 2. And then in the denominator, I'm going to have just x plus 2. So the temptation here is to cancel the expression x plus 2 from each of the numerator and denominator. But again, between that x plus 10 and the x plus 2, we have addition. So looking at that, we cannot cancel because of that addition. So we'll instead simplify that numerator, combine as much as we can, and then as a final step, we'll see if there's anything else that can cancel. Sometimes there will be in that last step once we've simplified everything in that numerator. So looking to simplify there, I've got parentheses around x plus 10 and x plus 2. According to the associative property, I can just drop all of those parentheses, so I really just have x plus 10 plus x plus 2 all over x plus 2. And when I combine like terms in that numerator, I'm going to get 2x plus 12. And that's divided by x plus 2. And so at this point, the most that I can do with that numerator is to factor out a constant 10. So I'd have 2 times the expression x plus 6, and that's divided by x plus 2. And there's nothing here that will cancel. I don't have any factors in that numerator that are the same as factors in my denominator. So it's fully simplified. If we summarize this one, what did we have in that numerator? We had addition. And did it cancel immediately in that first step? We could not. There was nothing that could cancel. So we had the same expression, x plus 2, in each the numerator and denominator, but because it was something that we were adding in the numerator, nothing could cancel. Now, I'll do one more example. And this one is going to look exactly like the last one, except the operation that I'm going to have will be multiplication. So, okay, I've separated my screen out here. So I'm going to have a new example, and I'm going to have a rational expression. And in this numerator, I'm going to put x plus 10 times x plus 2. And then in the denominator, I'll have x plus 2. Now, something important to note with rational expressions is that when we have that expression x plus 10 times the expression x plus 2, we're just using parentheses. But between there, those parentheses, there's implied multiplication. And it's implied by the parentheses. So we don't have an actual multiplication symbol. The parentheses themselves, having one on each side, means that we are multiplying. So that's our operation we're looking at. So because we have a factor of x plus 2 then in that numerator, something that we're multiplying, it will cancel in this case because of that multiplication. So going from there, x plus 2 will cancel here, it'll cancel here. I'll simply be left with a 1 in that denominator once that x plus 2 cancels out of it. And in the numerator, I'll have x plus 10. We should note that since we canceled that factor of x plus 2, x cannot equal negative 2. And so when that is all said and done, we have the expression x plus 10 for values of x that are not equal to negative 2. And if we summarize this last one, the operation we had in that numerator when we started was multiplication. And looking at, could we cancel something? Yes, we could.